All right, we are back for day number 3 of geotechnical engineering. Let's get our brain moving. Come on. And let's think about what we did yesterday. All right, yesterday we talked about geotechnical engineers have to know a ton about the layers of the earth. What's the most important layer that they really need to focus in on?
Crust.
The crust of the earth. And up here on this picture, this little model, that it makes it look very thin. But we know that the crust can be made up of a whole lot of different layers. You can dig the part we walk around on and come to topsoil, dig a little deeper.
Sand, clay, bedrock.
Are all the layers of the earth in the crust always exactly the same depth? No. Depends on where you are. You could have a really thick layer of soil followed by just a thin layer of, and then you could have a whole lot of clay, all right? And then how do people find out what layers are underneath them to build a structure safely? Jacob?
Core sample.
They have to take what's called a core sample. If you were trying to tell a kindergartner what a core sample was, what would you tell them so that a kindergartner could understand? Trent?
I would say you stick a clear tube in the ground, you twist it and you yank it back up, and you see what all of the materials are.
Okay. Now, do you think a geotechnical engineer uses a plastic tube like we used yesterday?
No.
What might they use, Kirsten?
They would use a big giant machine that's really expensive.
Would it be made out of plastic?
No.
What would it probably?
Out of metal.
Probably out of metal. All right. But we know we can't bring that huge piece of equipment in here, right? So we use models in science to mimic those big pieces of machinery. So that's what we focused on yesterday. And we ended our lesson by making a prediction, and this is like a preliminary prediction to the villagers, because we still might have to do a few more tests to decide what site is really the best for building that tar pool. So I'm going to hand out your journals, and I know you're already an expert. We're just going to do this top part. We're going to be thinking about erosion. We're going to be thinking about what part of the river do you think will change the most, and you're going to either circle straight or curved. And then you're going to think about what parts of the river do you predict will change the least, and why do you think that, okay? And then we're going to do 2 quick activities with erosion. Turn in your journals to 3-7 at the bottom. We're only doing the top part, just the prediction. What parts do you think will change the most and the least, and why do you think this? Should just take you about 2 minutes. Do not do the bottom. All right, let's take a minute to discuss real quick. And then we're going to actually look at some maps of erosion taking place. All right, what part of the river did you predict would change the most over time? Straight or curved? Can you show me with your arms, straight or curved? Ah, everybody's curving all around. All right. What about what part of the river will change the least? Show me with your arms. All right. Now let's think about everybody. Straight parts of rivers will change the least over a span of time. So this happens to be a river way back in 1920. Now, that is about the time that my grandparents were born, so that's probably your great-great-grandparents, not quite 100 years ago. So let's take a peek. Do you see any curvy parts? Stop me when I get to a part that you would not build a tar pool.
Stop. Stop. Stop.
Stop. Oh, I heard a louder stop on that curvy part.
Stop. Stop. Stop.
Okay, now, I'm going to fast forward 54 years later. What year would that be? This is 1920. Add 54 years to it. Trent?
1974.
Let's see. Drum roll for Trent. A map of the same river, 1974. Now I'm going to lay it right on top. Look how pronounced. Because that water is rushing so hard, those big curves take place. That is erosion. Look at that. It way went out there. Pretty cool, huh? Why does that happen? Make your brain think. I need a volunteer. Someone who can articulate.
And I think this curved part will change in the most time because the part of the river when it curves and plus the water's going really fast, so it just slams into and has to go the other way. So it just keeps over time it keeps like splashing into it and it keeps like breaking it to make it change, and then change. So at least over time, I think the straight part, because if it's straight, it's not going to be slamming against the side, so it's just running through, and it's just going to be calm.
Okay. Wow. Say way to go, Bryce.
Way to go, Bryce.
Does anybody have any tough questions before he gets his prize?
Bella. Why does the water slow down on the straight parts? Why doesn't it keep on going faster?
Well, maybe it can kind of keeps up with the pace, but it just doesn't slam against the sides as much as on the curves.
All right. I want to be in your class someday. Lesson 3 deals with introducing the kids to erosion. It also introduces the students to the compaction of the riverbank. So we start out by looking at erosion and really honing in on what does that mean. I usually tie in, because we're near the Ohio River, I kind of take a quick little imaginary field trip down there. What are you going to see as the water rushes by? Are you going to see immediately big changes if we went down to the Ohio River and then we came back and went down the next day? Of course not. So I really try to pull in some different things just in our vicinity that will let kids know this happens over, hundreds and maybe thousands of years.